Hello everybody and welcome back to the channel. I'd like to thank everybody for watching and all the new subscribers. I really appreciate it. Today I got called over to this building. Apparently they're having an issue with the resin mixing station on this composite winder. Basically the resin mixing station just mixes two parts of resin and makes it one, and then they do some kind of curing process or something like that, from what I understand. So according to them, they're saying that the resin mixer has no power. So I'm kind of looking around for, I think this is the resin mixer, and it looks like that our switches are in the on position. So I'm gonna go ahead and start investigating and trying to see what I could come up with and what happened to this thing. So let me dive into this. Okay, so it looks like the resin mixer power cords are coming down from the bottom, and it looks like they're feeding into this outlet right here. So we're gonna have a look at that. Let me get my outlet tester and verify that this thing has power. And it might be a blown fuse or a trip breaker inside this panel. I don't know yet. Let me verify that there's power. So I went and grabbed my power, my outlet tester, and I'm gonna try to find out if the source voltage is out or if the internal control panel breaker is tripped or what's going on inside. So I just plugged in my tester and it looks like there's no power on at least this outlet, and there is no power on this. So they basically do not have power for this resin mixer. See what's going on with that. We're gonna have to trace this outlet receptacles back to its source. So it looks like the receptacles are coming out of this raceway up into here somewhere. So let me trace this back and we'll come back to where this thing actually goes. Okay, after some tracing, I'm seeing that it comes through the raceway into the bottom of this panel, and it must come through here. So I don't have a key for this, but I have a key for this side. So let me open it up and see what things look like in there. So I don't see any of these breakers out. I don't see any of these breakers out. I'm wondering if it runs off of one of those fuses up there. Oh, there we go. Okay, so I see one of these. Can you guys see this? I see one of these breakers out. Let me flip that up real quick. I don't think any of them are supposed to be tripped. Okay, so now it has power. That must power that box. So okay, so this has power. Our switches are in the on position, and it's showing an active fault. So it might just be the fault because the heaters aren't up to temp. I guess this thing heats up resin until it becomes fluid enough to run. But I'm seeing red. Hold on. Let me try to get into the fault. I don't know why this is red. Reset, and it's not resetting. What's going on with that? All right, boys, it looks like we got something going on here. We got this big exclamation fault light lit up. This turns on the mixers. This should reset the fault, but we're not resetting the fault. Our heats are coming up, so I don't think it's our heaters that's faulted, and it says inverter A fault. But I'm looking at two motors down here, and one does say A and one does say B. So inverter A fault. What does that mean? Does that mean this inverter's bad? Inverter faulted out? Well, the inverters would be inside the panel. So let's get this thing cleaned up from the fiber, and then we'll get it at least look inside the panel in case there's a breaker trip or something going on in there. It's probably just a trip breaker off of that mixing motor. So let's go ahead and check it out. So I went and grabbed the Gojo wipes, boys. Never leave them home without them. Here we go. Let's set these on this table real quick. Maybe get some gloves on. Get some gloves on so I don't dirty my nails. All right, Gojo number one. Let's just get this surface cleaned up just in case. I don't want to touch any of this fiber. It's highly conductive, and I don't want any of it getting inside of the panel. All right, so we got the panel all wiped down. We got all the fiber off the top and the side. I'm gonna change these gloves and get this bad boy opened up. Let me go grab my meter just in case we have to do some diagnostic. All right, boys, I got the meter now. So let's get this panel opened up. Looks like we need a key for both, which I have one. It's the same key as that other panel I just opened. So let's go ahead and get this turned off. Open up the door. So now let's get this bad boy. So with the door open, I'm gonna go ahead and power it up and kind of see what's going on. I don't see any breakers tripped. Here's two breakers that I would think would trip, but I don't see anything tripped, and I don't see any other breakers in here. I see 1, 2, which who knows those go to. Okay, so yeah, I don't see any breakers tripped. So let me go ahead and power this bad boy on, and let's see what we got here. Let's get this first key on, second key on. We get let the HMI cycle on. We will reset, and we still have our fault, and we'll go to fault. Yeah, the fault was inverter A fault. Inverter A fault. I'm guessing that's inverter A. I'm guessing that's inverter A, boys. He's not even on. Hello? Where did you go? All right. I have no idea. There is no breaker trip, so a breaker must not feed that. And it is a single phase inverter. One is on, which must be B, and A is off. B inverter is on. High pressure A, high pressure B. Tank fill A, tank fill B, but he is off. Oh crap. All right, let me get a voltage reading off this guy and see if we have voltage coming in to the supply side of this inverter. Okay boys, we're back, and I went and got my 11-in-1 screwdriver. So I'm gonna go ahead and take the cover guard paneling off of this, and let's go ahead and open up this, and I'm gonna try to find my supply side wiring for this inverter and see what kind of power we have running to it, and we'll see what's going on with it. So I'll open up this one and try to pull the cover off. I think these Hitachis have two covers. One is for the control inputs and one is for the power wiring, which is at the bottom. All right, here we go. Okay, and we will look at this bad boy. Let me get a flashlight. I'm not feeling this. I'm not feeling this. I don't like the look of this. It doesn't feel good. Inverter's out. Inverter doesn't just go out. All right, so we got our meter. Let me set it to volts AC, and it looks like it's single phase. So we'll see what it's running. If it's running 120 or 208. I don't see any breakers trip. I think these are fuses. Yeah, this is a fuse block right here, and there's fuses right there. But usually in the control panels, what is this? A power supply? Power supply. Let me see if we got some voltage on this power supply. 116, and I'm assuming it's 24 volts out. Yeah, 24 volts out, but that's probably feeding the PLC. And then we got our safety, which on our safety K1 and K2 are met. Yeah, so this guy's just out. So let's try to get up in there in his terminal wiring and see why he's acting up. So I don't know if you guys can see in there, but you have three leads that are going to be I think it's U, V, and W that go to the motor, and then you have 2 leads coming in. So I'm going to go ahead and probe those first 2 leads, and let's see what we got here. All right, I got my probes on those 2 leads, and we're only showing 2.3 volt, 2.3, which is nothing. So it looks like we don't even have voltage. So what do we got here? So let me put my flashlight in there so I can at least see what's going on. I can't see in the dark. And it looks like, luckily, the wiring is labeled. So one of the wires is number 2 and one of the wires is 41. So I'm guessing our number 2 is a common. I'm seeing the number 2 right here. Number 2 right here, so that must be a common. So what is the common? Is it, I think it's 120 volts. I think this is a 120 volt supply voltage, yeah. And then what is the other one? 41. This looks like 41 right here. How can I see if there's power? Let me see. Number 2, 41. Okay, 2. Okay, so it says number 2 and 41. Here's number 2, here's 41. All right, boys. So it looks like our number 2s are common, bam, and 41 is our supply side for this bad boy. So on the bottom side of this fuse block, I'm probing, and I got 2.3, which is exactly what we had at the terminal. And let me probe at the top, and we have 116. So we have 116 at the top. We don't have 116 at the bottom. So let me probe the one next to it, which is 51, and that is 116. Let me probe 41, which is our faulted, and that's showing nothing. So it's showing that, I think it's a fuse. If it's a fuse, it's a bad fuse. I think these just swing down. Okay, there we go. Okay, let me get some light on that. I don't know if you guys could see that. Oh, is that a door? Oh, it's a door. Oh, okay. Let me get that bad boy. Oh, he's blown, boys. Let me do a continuity check on him real quick. And yes, he's blown, boys. Well, no wonder why you don't want to light up and smile at us, because you got no power. You got a blown fuse. What did you do to this fuse? Why would this fuse just pop like that? I don't know. Anyhow, let me go try to dig up another fuse, fellas, and get back to this bad boy, and then we'll see what the cause of death was. What would the cause of death be on the supply side? Why? Is he blowing out? Are you going out, buddy? Let's go ahead and get a fuse and get this fuse replaced. We'll go ahead and sacrifice one fuse and see if we have to troubleshoot further and see what's going on with this. I don't think it's going to be a fiber short. Might be a line-to-line short or a ground fault. But let's go ahead and get it changed out, and let's see where we're at. once we do that. All right, fellas, we're back, and I got some fuses that I had to run out and buy. These are a 5 amp 250 volt fuse. They're the 20 millimeter by 5 millimeter glass fuse. These are fast acting fuses, not time delays. So I had to go buy these bad boys from a little fuse company that's right here up the street from this building. And let's go ahead and get this panel open back up and see what we can see. We got the panel open back up, and unfortunately for us, nobody came and fixed it yet. So I guess we're gonna have to take care of it. So let's see what's going on here. I'm gonna get this bad boy powered back up, and I'm gonna use these keys, which are also used to open the door, to turn on our 2 separate disconnect sources. Okay, so we have power. So originally we had no power to the outlet, which could have been caused by fiber, I don't know. And now on the second part of this, we did some troubleshooting. We noticed that after we powered everything up, we had a fault on our HMI screen, and as soon as you hit to call for what the fault would be, it's saying inverter A fault, which is highlighted in red, which is a big issue. And you know you're in fault condition because your fault condition lamp is illuminated. So we did some troubleshooting, and we found that there was a bad fuse, which is a 5 amp fuse for that inverter A fault. So we're gonna go ahead and we finally found the fuse housing. So we're gonna go ahead and swap that fuse out, and let's see what happens. So we went out and bought 5 fuses because it was a minimum of 5. So I'm gonna go ahead and use one of these bad boys and get it up into this little swinging door here, and let's get this thing hopefully powered up. You know what? Before I put that fuse in, I'm gonna go ahead and power this bad boy down. We'll put the fuse in, and then we'll start everything back up, just for safety. Just for safety, boys. I'm not taking no risks today. Okay, all right, so we got the fuse in, get that closed. Let's get this thing powered up. Now we got power to both drives. So this is a resin mixing station, so obviously they use heated fluid to go into what looks like a mixing or a pumping motor. So they must heat the fluid for the viscosity to keep it fluid, to make the fluid like fluid, because it's probably very sludgy until they add some heat to it. So we're gonna go ahead and let this thing come up to temp before we turn it over to the operators and have them test it out and try to see if it's gonna blow that fuse again for whatever reason. But if it blows that fuse, that's on the supply side of the drive, not the load side. So I'm interested to see what happens here. So I'm gonna leave this, I'm gonna leave my cover plate off for now, and we'll go ahead and keep an eye on things. So let me go ahead and get a hold of the operator, and let's see what they can do for us. Okay, so I just reset the fault. Our fault light went out, and it looks like we're coming up to temp. So it looks like we are at 49 degrees Celsius. This is 38, 49 set point, 45. So we're getting close to temp. So let's go ahead and let this thing heat up, and then we'll call them to try to run it and see if they're getting flow. As long as we don't pop any fuses, I'm out of here, boys. You want this to come up to temp before you try to run it? Okay, so it looks like on this unit we're running 2 groups of heaters, and this is a reservoir heater, a pump heater, and a dispensing hose heater, and a heated feed hose, which goes into some kind of bath or pot or whatever. And then the second group would be obviously pump B, the reservoir, which would be what holds probably the large volume of resin. The pump, so going through the pump head is probably a heated pump head, so you get all your flow. The dispensing hose, or your feed housing, where that's probably where you're actually spitting out your resins. So it looks like we reset. Everything is looking good. Our temperatures are very close. They're not there yet, but they are getting there. So let's give it a couple more minutes. We'll grab a hold of this operator and see what he can do. So the drive went out, so I changed the fuse on the drive and it came back on, right? So I want to see if it's going to go out again or if there's any other issues. The fault got reset as soon as I powered the drive on. So it looks like we're up to temp. Are you ready to run the pumps?
All right, you can turn it on.
All right, so you want me to flip this switch?
Yeah.
All right, ready?
Yep.
All right. Okay, so you got the 2 parts?
Yes, sir.
Looking good?
Yeah, everything's running pretty good.
Okay. All right, I'm gonna close this up and I'm out of here.
All right, go ahead, turn it off.
All right, we're good? All right, sweet. Let's go. Let's go. Okay, so we just tested the operation on this thing and everything looks good so far. So I'm not gonna push my luck here, and I'm gonna take the win as we get it and seal this bad boy back up. So once I seal this bad boy back up, I will turn it back over to them, hang around while they run it for a little bit, and then we will get out of here. So let me go ahead and button up the cover panel for this drive. All right, boys, this was an easy one. I don't know what caused that fuse to blow, and I don't know what caused the breaker to trip for the whole resin mixer as a whole, but stranger things have happened, so I'm not gonna question it. If I need to dig further, I'm sure I'll get a call back, and we're gonna take the win for today. Let me button this bad boy back up, and I'll turn it back over to him, turn it back over to the operators. And I just really want to thank everybody for watching and everybody for subscribing. And if you have not yet subscribed, please subscribe, because we do troubleshooting daily. We do industrial work is all we do. This is a rare glimpse into the industrial industry and machinery and equipment that most people will never have the opportunity to see. So I appreciate the view, guys, and I just want to thank everybody once again. I appreciate it, guys. Later.